Okay, hello, this is Dr. Hanaa Assil, and this is the second part of the general review for the IGCSE Cambridge. This is the core, so remember that the core is included in year 9, pre-IG, and it is also included in year 10 or above, which is the IGCSE supplement or extended syllabus. So, let's continue. We stopped at calculations, and you should know that basic core syllabus requires calculation of molecular mass, which is also needed for the extended. Remember, the molecular mass is just the addition of all the masses of the atoms in the molecule. So, for example, here we have a molecule that has uranium with 2 oxygens and 2 fluorines. So in order to fill that table, the number of oxygen atoms is 2. You should realize that from the periodic table, you look at the big number or the mass number. The mass number of oxygen is 16. That means I have 2 times 16. Now, fluorine, I also have 2 fluorine atoms. Each of them has a mass of 19, and that means the molecular mass of that is 2 times 19. Now, the total molecular mass or formula mass of the compound is just the addition of all of these, 238 plus 32 plus 38. So this is the overall molecular mass or formula mass of the molecule. Sometimes we are required to get the percentage composition. So for example, if I say what is the molecular mass of sodium hydroxide, it's the mass of sodium plus oxygen plus hydrogen. So that comes out to 40. What is the percent sodium in that? So the part of the sodium is 23 over the total times 100, that is percent sodium. The part of the oxygen over the total times 100, that is the percent oxygen. And the part of the hydrogen over the total, that's the percent of the hydrogen. So that's how we get percent of something in a molecule. Sometimes we're given masses and we're required to calculate. So for example, this question says 13 grams of zinc reacts with sulfur. It gives 19.4 grams of zinc sulfide. So what is the mass of zinc sulfide if we are starting with 3.25 of zinc? So of course, in this case, we just do cross multiplication. 13 gives 19.4 of the sulfide, so the 3.25 will give how much? So this is basic calculations in the IG chemistry. What is the difference between physical change and chemical change? Remember, physical change, no new substances are made and it's easily reversed. So for example, if we get ice and we heat it, it melts, or water, it boils or freezes. All of these are called physical changes because we did not change the substance itself. But if we do any chemical reaction, then a new substance is formed and we cannot easily reverse it. So for example, if I heat iron with sulfur, it gives me a completely new compound. That's a chemical change. But if I just add iron to sulfur, it just forms a mixture, and this can be separated easily. Now, what is oxidation? What is reduction? Your basic definition of oxidation is gain of oxygen. Reduction is loss of oxygen, and a reaction that involves both is a redox reaction. So a redox reaction involves both oxidation and reduction. So for example, if I have copper oxide plus hydrogen, what happened to the copper oxide? It became copper, and that means it lost oxygen. Loss of oxygen is reduction. What happened to the H2? It became H2O. That means it gained oxygen, and that is oxidation. You should remember, reversible reactions are reactions that go both forward and backward without going to completion. So the reactants form products, but the products break down again to form reactants. this is a reversible reaction, and to indicate that a reaction is reversible, we draw this double-headed arrow in the middle. This indicates that the reaction is reversible. What is meant by exothermic and endothermic reactions? You should know. Exothermic reaction is a reaction that gives out heat. So, a reaction inside the flask gives out heat. It gives out heat to what? To the surrounding solution. So, the temperature of the solution increases or the reaction becomes hotter. So, combustion or burning is always exothermic. Endothermic, the reaction takes in heat. It takes in heat from what? The reaction inside the flask will take in heat from the surrounding solution, and that means the temperature of the solution, if I have a thermometer in there, the temperature would decrease and the reaction becomes colder. So, for example, if I am changing solid to liquid, in order to change a solid to liquid, I have to heat the solid. That means we're giving the solid heat. That is an endothermic reaction. You should know, of course, that when we draw an energy profile or a diagram like this, the reactants have a certain amount of energy. Now, if the reaction is exo, that means the reactants will lose energy, and that means the products will have an energy lower than the reactants. So, if the products have energy lower than the reactants, that is exothermic. Now, to go from reactants to products, we have to go through activation energy. So we need to give the reactants a minimum amount of energy in order to start. That's called activation energy. Activation energy is the difference in energy between the reactants and that top there, that is activation energy. Now, the amount of energy given out by the reactants is delta H. And for an exothermic reaction, delta H is negative because the energy of the products is less than energy of reactants, and the difference between them is the delta H, or the energy change. Now, if we're talking about an endothermic reaction, endothermic means the reactants take in heat, and that means the products would have more energy. So how do I know this is endo? Because the products have higher energy than the reactants. Where is the activation energy and where is the energy change? Again, activation energy is the difference in energy between reactants and the top. Energy change, or delta H, is from reactants to products. So in this case, the arrow is going up, and that means that the delta H is. So let's review the types of reactions. What are the types of reactions that we have? Neutralization, of course, we said is reaction between acid and base to give salt and water. What other reactions do we have? We have substitution reactions or displacement reactions. A displacement reaction is one in which a more reactive element displaces the less reactive element from its compound. Precipitation is a reaction that gives something that is insoluble. So we add two solutions and they react to form a solid or an insoluble substance. This is precipitation reaction, and we call that solid a precipitate. What do we mean by thermal decomposition? It is the breakdown of a compound using heat. So if we heat a compound and it breaks down into two or more substances, that is called thermal decomposition. What is an addition reaction? If two or more substances react to form only one product, that is called an addition reaction, when only one product is formed. What do we mean by double decomposition? When two compounds exchange radicals. So I'm starting with sodium chloride plus silver nitrate. This gives silver chloride and sodium nitrate. That is called double decomposition. What's a photochemical reaction? A photochemical reaction is a reaction that needs light to start. So the light provides the activation energy needed for the reaction to start. So we have reaction of alkanes with halogens in presence of UV light. This is a photochemical reaction. And of course, also we know photosynthesis. Photosynthesis is a reaction that needs light, so it is also an example of photochemical reactions. What are the factors that affect the rate of a reaction? Remember, temperature. If I increase the temperature, it increases the rate of the reaction. So if we're drawing a graph and we have for a lower temperature, that's the red graph. If we're told to draw a graph for higher temperature, that means faster reaction, then it is a steeper slope. If everything else is the same, then it ends up with the same final volume of product or volume of gas. If we're asked why is it that higher temperature increases the rate, of course that is because particles gain more kinetic energy, move faster, so more frequent collisions. Pressure. If I increase the pressure of a gas, and this applies only to gas, I increase the pressure of the gas, that means the particles are nearer to each other, more frequent collisions, so we increase the rate of the reaction. Also, if I repeat the experiment, but after crushing the solid or using powdered reactant, then this increases the rate. Of course, that's because we have larger surface area, so more collisions. Concentration of reactants. If I use a more concentrated acid, then the rate increases because we have more particles colliding at the same time. Okay, what's a catalyst? You should know that a catalyst is something that increases the rate of a reaction without being changed. So if we have this energy profile diagram, if we don't use a catalyst, the activation energy is high, but once we use a catalyst, it lowers the activation energy, so the reaction is faster. And this is for both exothermic and endothermic. So what happens is the catalyst provides an alternative pathway that lowers the activation energy. And you should know that if I do an experiment A, then changing anything that makes it slower would give graph 1. Anything that makes it faster would give graph 2. When do we have graph 3? If I use more reactant, then I end up with more gas. How do we study the rate of reactions? Well, if it's something that gives out a gas, then either measure the volume of gas every minute or measure the loss in mass every minute. So, you should know that organic compounds are covalent compounds of carbon that were originally obtained from plants and animals. So the core talks about alkanes, alkenes, alcohols, and carboxylic acids. For the extended syllabus, we also have esters. What's a hydrocarbon? Hydrocarbons are organic compounds made up of only carbon and hydrogen. So this includes alkanes and alkenes. They have only carbon and hydrogen, so they are hydrocarbons. A functional group is part of the molecule that determines the chemical properties of a group of organic compounds. So you should know, if we're talking about alkanes, they all have single bonds between the carbons, so that's a functional group. Alkenes would have a double bond somewhere, alcohols would have an OH somewhere, and acids would have this group, which is C double bond O, OH. These are called the functional groups. What do we mean by homologous series? It's a group of organic compounds having what? Having the same general formula, the same functional group, and they would have same chemical properties. You are required to know the general formula for each of these. So an alkane, the general formula is CnH2n plus 2. That means the number of hydrogens is twice the carbon and then add 2 more. Alkenes, the number of hydrogens is twice the number of carbons. acids. Now, what about alcohols and carboxylic acids? If you know that alkane or CnH2n plus 2, now to make it an alcohol, you make it H2n plus 1 and we put an OH instead of the hydrogen that we removed. If we're talking about carboxylic acid, then it is CnH2n plus 1 and we put COOH, which is the functional group instead of the other hydrogen removed. How do we name organic compounds? The first thing is count the number of carbons. If we have only one, it's meth, 2, eth, 3, prop, 4, bute, 5, pent. And then you determine is it meth what or eth what from the functional group. So if you can see only single bonds, nothing else, then the name should end with ane. So methane, ethane, propane, and so on. If it has a double bond somewhere, then it should have an ene. So ethene, propene, butene, and so on. If it has an OH, only OH, it is an alcohol with an "ol" at the end of the name. If it has an OH and a C double bond O, so the OH and the C double bond O, that's an acid. So its name should end with something oic acid. So how do we name this? We have how many carbons? 2 carbons. That means eth. Which of the functional groups? It has an OH. So this is ethanol. What about this one? How many carbons? 4. So the name must start with bute. Now it has a double bond somewhere, so it ends with ene. But I need to identify the double bond is on which carbon. You count from the side that gives the lower number. So this is on carbon number 1. So we call it bute 1-ene. This is something that has 3 carbons, prop. It has only single bonds, that is an ane, propane. What about this one? This has 1 carbon, so that's meth something, but it also has double bond O, single bond OH, so this is an acid, so it's called methanoic acid. Please learn all of this. Now, types of formula. If we're asked to draw displayed formula, that means we show all the atoms and all the bonds. So let's say this would be displayed formula of propane. But if we're required to write structural, then each carbon has how many hydrogens around it? So the carbon on the left has 3 hydrogens, so I write it as CH3. The carbon in the middle has only 2, CH2. The carbon on the right has 3, so that is CH3. That's how you write structural formula. What if he's asking for molecular? Molecular formula means total number of carbons, total number of hydrogens. So this is C3H8. If we're asked for general formula, then the general formula is the one that has N. CnH2n plus 2 because this is an alkane. Uses. You should know that methane is the main constituent of natural gas, so it is used as a fuel. Ethene is used to make ethanol or polymers, and the ethanol is used as a fuel or as a solvent. Reactions, we have complete combustion. That means a lot of oxygen or excess oxygen, and any organic compound. Complete combustion would give CO2 plus H2O, carbon dioxide plus water, and then you balance. But if we're talking about limited amount of oxygen, or sometimes we say lack of oxygen, this is called incomplete combustion. So when we ask what is incomplete combustion, it is the burning or the combustion in limited amount of oxygen. In that case, what we get is carbon monoxide plus water, and the problem with carbon monoxide is it is poisonous or toxic. Another reaction of alkanes, remember alkanes are not very reactive. We regard them as not reactive. They do only a limited amount of reaction, so they do combustion, they do cracking. If we say what is meant by cracking, cracking is the breakdown of long chain hydrocarbons into shorter chains. What are the conditions for cracking. I need to do what? Aluminium oxide catalyst, 400 to 700 degrees Celsius. These are the conditions for cracking. So we write them if we are required to write conditions. Now, if we're breaking a long chain hydrocarbon like C8H18, either we break it into alkene plus alkane or alkene plus hydrogen. So cracking would either give alkene and alkane or alkene and hydrogen. So we always get alkene, and then we can either get alkane or we can get hydrogen. Substitution reactions. We said substitution reactions of alkanes need UV light. So this is an example of a photochemical reaction. Now, substitution means you're going to remove one of the hydrogens and put a chlorine or a bromine instead of it. So my other product would be the H and the other chlorine or the other bromine. So remember that we can remove any of these hydrogens and put one halogen instead of it. So for propane, I can either put it on one end, so that is called 1-bromopropane, or I can put it in the middle, so it's on carbon number 2, so this is called 2-bromopropane. Of course, to test for alkenes or to test for unsaturation, we add bromine water. With alkenes, it changes from reddish brown to colorless or from orange to colorless. With anything else like alkanes, there is no change. Alcohols have OH somewhere. So this is methanol, ethanol. This is propane 1-ol or 1-propanol. That is where the OH is. We said we count from the side that gives a lower number. So this is 1-propanol, not 3. So this is 1-propanol or propane 1-ol. This is 1-butanol or butane 1-ol, and that one has the OH on carbon number 2, so it is 2-butanol. How do we prepare ethanol? This is important. This is ethanol, and we can prepare it by one of two methods. Either I use hydration of ethene, and remember, hydration of ethene means ethene plus water in the form of steam, because the temperature is 300 degrees Celsius. So remember, hydration of ethene conditions are we add water, phosphoric acid catalyst, 300 degrees Celsius. We can also say 60 atm. Where do we get ethene from? We get it from petroleum. Remember, all organic compounds, the raw material is petroleum. We take petroleum, we do fractional distillation because it's a mixture of liquids, and we do cracking. It gives ethene. So this is one method of making ethanol. The other method is from glucose. So we can have glucose, add water, yeast, 37 degrees Celsius or 35 degrees or 30 degrees Celsius, anything within that range. That gives ethanol. So this is called fermentation. Now, where do we get the glucose from? We get it from sugar cane. So you should be able to tell the advantages and the disadvantages of each method. Remember, hydration of ethene, we just have ethene plus water, and the only product is ethanol. So that's a pure product and a fast process. But the problem is, with hydration of ethene, we need crude oil, and this is a non-renewable resource, and it requires high pressure and high temperature, so this is more expensive. With fermentation of glucose, the glucose is obtained from sugar cane, and that is a renewable resource, so that's an advantage. And we don't need to heat it to a very high temperature, so it is less expensive. However, you should know that when we do fermentation of glucose, it's a slow process. We add yeast to the glucose. This takes some time, and the product that is obtained needs to be purified because we end up with yeast ethanol and water. The yeast has to be filtered off, it's a solid. And I have a mixture of ethanol and water. Of course, to separate it, I need fractional distillation. Acids must have C double bond OH, so we have methanoic, ethanoic, propanoic, and so on. So, reactions of acids. Of course, this is an acid. It can react with a metal. Metal with acid would give salt plus hydrogen gas. So, if I put sodium on ethanoic acid, we're going to remove the acidic hydrogen. The hydrogen, add the C double bond OH, and we put the metal instead of it. So the product is sodium ethanoate plus hydrogen gas. Reaction with a base, of course, acid plus base gives salt plus water. So again, this would give sodium ethanoate plus water. Reaction with carbonates would give salt plus carbon dioxide plus water. So again, sodium ethanoate plus carbon dioxide plus water. Polymers, what are polymers? They are large molecules made by joining many small molecules together. So the small molecules are the monomers. So monomers are small molecules that can be joined to many other molecules to form a long chain, and the process of joining many small molecules together to form a long chain, that is polymerization. Now, polymers are basically the plastics that we use at home. So, plastics or polymers are used in making plastic bags, plastic bottles, plastic ropes, and so on. What is the disadvantage of the use of polymers, or what are the problems of the use of polymers? Remember, they are non-biodegradable, so they accumulate in dump sites and in oceans, and when burnt, they release toxic gases. How do we draw a polymer? We look at the double bond. Remember, the types of polymerization that we talk about in pre-IG is addition polymer. Addition polymer starts with an alkene. We open the double bond, make it into a single bond, bond on the right, bond on the left, and then we add the hydrogens or the bonds that were originally present. Remember, if I'm starting with a monomer called ethene, then the polymer is poly, the same name. Even though the polymer, notice that the polymer doesn't have a double bond. So the polymer is not an alkene, it would not react with bromine water, but we call it polyethene because it was made from ethene. What if we start with propene? Again, we look at the double bond, write it as a single bond, bond on the right and bond on the left to indicate that we're joining it to many other molecules like it. And then we look at the bonds that were originally present. So the carbon on the left was bonded to H and H. The carbon on the right was bonded to H and that other group, which is CH3. So if we're starting with propene, then the polymer is polypropene. What if we're talking about butane? Again, look at the double bond. Don't write all the carbons after each other and that's it. We look at the double bond because this is where the monomers are joined to each other. So we write it as a single bond, bond on the right, bond on the left, and this is what we call the repeat unit. And then we see each carbon was bonded to what? The one on the left was bonded to hydrogens, the one on the right was bonded to a hydrogen, and all of that group, which is C2H5. And of course, the polymer of butane is called polybutane. Butene, again, look at the double bond, not anywhere else. This is written as single, bond on the right and bond on the left. And then determine each carbon is bonded to what? So the one on the left is bonded to a hydrogen and a CH3. And the one on the right is bonded to a hydrogen and a CH3 again. And of course, this is polybutane. Fuel. Fuel is a flammable substance that burns in oxygen to release heat. So this is an exothermic reaction. Fossil fuels are obtained from remains of plants and animals. So you should know that coal is a solid fossil fuel. Petroleum or any of the fuels obtained from it are liquid fossil fuels. Natural gas, which is methane, that is gaseous fossil fuel. But we also have other fuels like uranium-235, and this is used in energy, to produce energy in nuclear power stations, and hydrogen gas is used as fuel in rockets. You should know what happens to petroleum in order to obtain the different fractions. Remember, the petroleum, which is crude oil, is heated and vaporized, then cooled and condensed in the fractionating tower to give different fractions at different boiling points. You should know the names of the fractions, the arrangement of the fractions, and the uses of the fractions. So the ones at the top, the ones obtained at the top, are the ones that have lower number of carbons, lower boiling point. They are less viscous, more flammable, more volatile. These are the ones on the top. As we go down, then the ones down would have higher number of carbons, higher boiling point. What is electrolysis? Electrolysis is the breakdown of an ionic compound, that is molten or aqueous solution, by the passage of electricity. So we have electrolyte, which is an ionic compound with positive and negative ions. We have electrodes, which are usually made of graphite, and we connect that to the ends of the battery with a wire, which is a metal that has electrons. So in the wire, the negative electrons are attracted to the positive end of the battery and repelled away from the negative end of the battery. So the electrode that is attached to the negative end of the battery will have electrons in the wire coming to accumulate on it. So remember that the electrode attached to the negative end of the battery is negative, and that means it will attract the positive ions, which we call cations. So that electrode is called cathode. On the other side, we have an electrode that is joined to the positive end of the battery, and we said the electrons in the wire are attracted to the positive end of the battery, and that means that electrode will have less electrons. It's positively charged. It attracts the negative ions or the anions, so we call it a node. Remember, the metals or hydrogen will go to the cathode because they make positive ions. And the non-metals, chloride, bromide, and so on, are usually negative ions, so they go to the positive electrode. What happens, and we're talking here about the basic core electrolysis syllabus. So molten sodium chloride has Na plus and Cl minus. Of course, the Cl minus is negative. It will go to the positive electrode and form chlorine. So if you say what is the product at the positive, it's chlorine, and the chlorine is bubbles of green gas. Now, the Na plus will go to the cathode and become sodium, so this forms a gray metal of sodium. This is what is observed. What if we're doing molten lead to bromide? The bromide is negative, it goes to the positive and forms bromine, which is reddish brown fumes. At the cathode, the lead 2 plus forms lead, and this is a gray metal. Please note, is the question asking, name the product or what is observed? The name is bromine, for example, or lead. What is observed would be reddish brown fumes or gray metal at the other electrode. What if we're doing molten copper chloride, copper 2 chloride? Of course, the non-metal goes to the positive and forms chlorine, which is green gas, bubbles of green gas. The copper will form at the cathode, which is a reddish-brown metal. What if we have solutions? Now we have a choice. Remember that if we have concentrated HCl, we don't have only H plus and Cl minus, we also have H plus and OH minus from the water, and that means we have a choice between the chloride and the hydroxide. If this is a concentrated solution, we get chlorine. If it is a dilute solution, we get oxygen. The hydroxide reacts to form oxygen. Now at the cathode, it's just hydrogen, so we see bubbles of colorless gas. What if we're doing concentrated sodium chloride? Again, the negative ions are chloride or hydroxide. Concentrated means it is the chloride that would react to form chlorine. On the other electrode, we have a choice between Na plus and H plus. Please remember that Na plus would not form sodium if there is something else that is positive. So it is the hydrogen that would react, the H plus that would react to form hydrogen gas. Dilute sodium chloride, again, dilute means the OH minus is the one that reacts, so we get oxygen. On the other side, we said it is the H plus that would react to give bubbles of colorless gas. Aqueous copper sulfate solution. If we're doing copper sulfate solution, we have a choice between sulfate and hydroxide. Remember, it is the hydroxide that would react to give oxygen gas. At the cathode, we have a choice between copper and H plus. It is the copper now that reacts. The one that is less reactive is the one that reacts at the cathode. So we see a red metal deposit. Dilute H2SO4, again, we have a choice between sulfate and hydroxide. It's the hydroxide that reacts. At the cathode, we get hydrogen, which is bubbles of colorless gas. Electroplating, what is electroplating? It means covering a metal with another metal. So the ornament or the spoon that we want to cover will have to be negative in order to have the Ag plus going to the spoon. So what happens is the silver, we're trying to cover it with silver, then we have silver as the anode or the positive, and the silver electrode would dissolve, become smaller because it forms Ag plus. The Ag plus goes to the cathode and forms silver. So that means the silver metal deposits and the object is covered with the silver metal. So connect the silver rod to the positive end of the battery. Usually we clean the surface of the spoon with sandpaper to allow the silver to stick to it. Put the spoon in the beaker, contains silver nitrate solution. Connect the spoon to the negative end of the battery so that the Ag plus can go to it and form silver and deposit on the spoon. So remember that electroplating is the use of electrolysis to cover a metal, an object with another metal. Of course, why do we do electroplating? We said this is to protect the object from corrosion and to give the object a nicer appearance and more expensive value. Of course, more expensive value if I'm trying to cover it with something like silver or gold. Electroplating, while we're doing electroplating, the object should be cleaned to allow the silver to stick to it, and it should be rotated so that the object is coated evenly. Then we have a fuel cell. You should know that a fuel cell is a cell for which reactants are continuously supplied. So an example is hydrogen-oxygen fuel cell, in which we're continuously giving in hydrogen gas and oxygen gas. Of course, they react together to form water, and this reaction produces electricity. So this is an example of a fuel cell. Metals, you should know how to describe the structure of a metal, and you should know how to draw the structure of a metal. So metals are giant three-dimensional structure with regular rows of positive ions surrounded by a sea of free moving electrons. Now, physical properties of all metals, you should know all metals do what? All metals conduct electricity, all metals are malleable and ductile, all metals are shiny. Don't say high melting point or hard, because this does not apply to all metals. You should know that all metals conduct electricity because of the presence of free moving delocalized electrons. All metals are malleable and ductile because layers of positive ions can slide over each other easily. All metals are shiny. So these are the physical properties. Now, if we talk about chemical properties, you should know that metals in group 1 are more reactive than group 2. Metals in group 2 are more reactive than group 3, and group 3 is more reactive than transition. Now, within each group, the one down is more reactive than the one up. So, potassium, more reactive than sodium. Calcium, more reactive than magnesium. And then we have aluminium in group 3, and then transition metals. So, this is called the reactivity series. You should know that all metals react with oxygen. And when they react with oxygen, they give oxide. So magnesium, for example, will burn in oxygen to give magnesium oxide. And you should realize that magnesium burns with a bright flame. And the magnesium oxide that is formed is a white solid. Now, reaction with water. Some metals react with cold water. So the very reactive metals would react with cold water, and this gives the metal hydroxide plus hydrogen. So sodium plus water would give sodium hydroxide plus hydrogen. The other less reactive metals do not react with cold water, or they do not react quickly with cold water. They will react with steam, but when they react with steam, they form metal oxide plus hydrogen. So magnesium plus steam will give magnesium oxide plus hydrogen. Zinc oxide plus steam would give zinc oxide plus hydrogen. Of course, any metal below hydrogen in the electrochemical series or in the reactivity series would not react with water, and it would not react with acid. So remember the things like copper or silver or gold, no reaction with water, no reaction with acid. If we put sodium in cold water, you should realize that sodium group 1 has low density, so it floats. It reacts with cold water to form the hydroxide plus hydrogen. What are the observations? The sodium floats. It will move around because it's forming bubbles of hydrogen gas, and that will push it around. So we say it darts. And it melts or it disappears because, of course, the piece of sodium is reacting. It's giving out hydrogen, so it gives bubbles of gas or vigorous fizzing. And the bubbles of hydrogen gas may catch fire. Remember, the solution formed is sodium hydroxide. So if I put litmus or universal indicator, it would turn blue because the solution has become alkaline. What about calcium? Again, calcium reacts with cold water, so it gives calcium hydroxide plus hydrogen. But in this case, calcium is in group 2, so it has higher density, so the calcium sinks. We still get a lot of fizzing because it's giving out hydrogen gas, but the solution becomes milky because the calcium hydroxide that is formed is not very reactive. Now, when magnesium reacts, it doesn't react with cold water, it reacts with steam. So we need to heat it. In that case, we get magnesium oxide. So you will find that the magnesium burns with a bright flame, and we get white solid form. What about reaction with acids? We said any metal above hydrogen in the electrochemical series would react with acid to give salt plus hydrogen gas. So magnesium is reactive, it gives a lot of bubbles. Zinc would react, but it would give less bubbles, less reactive. Copper does not react. Copper is below hydrogen in the reactivity series, so it would not react with acids. Displacement reactions, we said a more reactive metal would displace a less reactive metal from its salt. So zinc, for example, would react with copper sulfate. Zinc is more reactive, displace it, so the blue color of the copper sulfate solution becomes colorless. The piece of zinc, the zinc solid, dissolves or disappears, and we get copper, so we see a red precipitate of copper. What is meant by alloys? Alloys are mixtures of metals with other elements, and this is formed by mixing the molten metals together and allowing them to cool. Remember that alloys, why do we use alloys? Because they're more resistant to corrosion and they're stronger and harder than pure metals. And if we say, why are alloys harder or stronger than pure metals? Because atoms of different sizes prevent the layers of the alloys from sliding over each other. Remember, we said metals are layers of positive ions surrounded by a sea of delocalized electrons. But if we have atoms or positive ions of different sizes, then the layers cannot slide over each other easily. Examples of the use of alloys, we have stainless steel, which is iron plus carbon plus nickel or chromium, and this is used in cutlery because it's hard and resists corrosion or resists rusting. Alloy of copper is brass, and brass is copper plus zinc, and it's used for ornaments and buttons. Why do we use aluminium for specific uses? You have to mention the property. So we use aluminium in food containers because it is resistant to corrosion. If we say why aluminium is resistant to corrosion, remember we said it has a protective oxide layer. So aluminium is supposed to be reactive, but it doesn't react because it has a protective oxide layer. So it resists corrosion, it's not poisonous, and it will not react with the food. Why do we use aluminium in aircraft bodies? It is light or low density and strong, so it can withstand the high pressure. Why do we use it in overhead cables? Because it's light and good conductor of electricity. Why do these are all uses of what? All uses of aluminium. Why do we use it in cooking utensils? Because it's a good conductor of heat and does not react with food. Remember that copper is used in electric wires because it's a good conductor of electricity. It's ductile, that means it can be pulled into wires. It can be used in cooking utensils because it's a good conductor of heat, and it can be used to make alloys, so it's bronze and brass. These are alloys with copper. What do we use zinc for? Galvanizing, covering the iron with a layer of zinc to protect it from corrosion. Or we use it in brass, so it is used as alloy with copper. Rusting of iron. Remember, iron reacts with what? With water and oxygen to form rust. So rust is the common name, but the chemical name is hydrated iron 3 oxide. So if we say the chemical name, hydrated iron 3 oxide, that's what we call rust. We need water and oxygen. What is the appearance of rust? It is reddish brown. Okay, to prevent rusting, we can use barrier methods. So this is covering the iron with something that would prevent reaction with oxygen and water vapor in the air. So for example, we could paint the iron, or cover it with oil or grease, or cover it with plastic. These are called barrier methods. Of course, we can also cover it with zinc, and that is called galvanizing, or we can do electroplating. So this covers it with another metal, and all of these are methods to prevent rusting. How do we extract metals? Remember that we get metals from an ore. So the ore is the raw form of the metal obtained from the earth. Now, when we get the ore, which method are we going to use? That depends on the reactivity of the metal. If the metal is very reactive, more reactive than carbon, then we have to get it by electrolysis. But if the metal is less reactive than carbon, I don't need to do electrolysis. We can do it by reduction of its oxide using coke or carbon. So when we talk about extraction of aluminium, you should know the ore is bauxite. So the ore of aluminium is bauxite, that is hydrated aluminium oxide. So we take the bauxite, heat it to remove the water, and we get alumina or aluminium oxide. Now we need to do which method? We said aluminium is more reactive than carbon, so we have to do electrolysis. It will not be displaced by carbon. Now to do electrolysis, we need molten aluminium oxide. In order to obtain aluminium, I cannot use a solution. I have to heat it, and I cannot use a solid. I have to heat it until it melts. So I need molten aluminium oxide, but aluminium oxide alone melts at 2100 degrees Celsius, which is very high. So we add cryolite. Why are we adding cryolite? To lower the melting point of the mixture, so we don't need to heat it to a very high temperature, which is more expensive. So the electrolyte is molten aluminium oxide plus cryolite, and the electrodes are made of graphite, which is carbon, and at the cathode we get aluminium. Of course, aluminium 3 plus is a positive ion that we go to the cathode and take electrons. And at the anode, we get the O2 minus, the oxygen ions, the oxide ions from the electrolyte will go to the positive and lose electrons and become oxygen gas. But we're giving out oxygen gas at an electrode that is made of carbon. So the carbon electrode burns in the oxygen produced to form carbon dioxide gas. That means that the anode or the positive electrode is being used up, and it has to be replaced from time to time. How do we extract iron? Well, we don't need to do electrolysis because iron is less reactive than carbon, so it can be displaced by carbon. The ore of iron is hematite. We do all of this process in a huge building called a blast furnace. Now, what do we put into the blast furnace? So the raw materials that are put into the blast furnace are coke, limestone, hematite, and air. We need hot air coming in from down, and at the top we put coke and limestone and hematite. Now, the first reaction that happens is that the coke burns in air to give carbon dioxide. This is an exothermic reaction, it's combustion, and it helps to raise the temperature of the furnace or to heat up the furnace. Now, carbon dioxide, I still have a lot of coke around it, so it is reduced to carbon monoxide, and it is the carbon monoxide that acts as a reducing agent to reduce the iron 3 oxide to iron plus carbon dioxide gas. What is the role of the limestone? We added the limestone to remove impurities, which are mainly sand, which is silicon dioxide. So, in the heat of the furnace, the limestone, which is calcium carbonate, breaks up to give calcium oxide plus CO2. This is an example of thermal decomposition. This calcium oxide is a base. It reacts with silicon dioxide, which is an acid, to form calcium silicate, which we refer to as slag. So the common name for calcium silicate is slag. What do we use the slag for? In the blast furnace, it floats on top of the iron, and this prevents the reoxidation of the iron. And when the slag is removed from the blast furnace, it is used in rod making. Then we have water. You should know uses of water at home and in industry. Of course, in industry, water is used for cooling, to make soft drinks, paper, and so on. So these are some uses of water. Note that in chemical reactions, when we do chemical reactions, distilled water is used, not tap water, because it has less chemical impurities. Remember that water may contain substances like dissolved oxygen, and we need that for respiration of aquatic animals. It may contain metal compounds, and this provides essential minerals for life. But it also may contain things that are harmful, like plastics. This is harmful to the aquatic life. Sewage, which contains harmful microbes or bacteria that cause disease. It could also contain fertilizers like nitrates and phosphates, and the presence of nitrates and phosphates in the water leads to deoxygenation of the water. So it removes the oxygen from the water, and that means the aquatic animals do not have enough oxygen to respire. So this is bad for fish or other aquatic animals. The nitrates and phosphates remove oxygen from the water. It could also contain detergents, and these are also harmful to aquatic life. How do we purify water for drinking? We do filtration to remove what? To remove suspended solid particles or insoluble solids. We could also add carbon, and this is used to remove any tastes or odors. And we also have to add a small amount of chlorine, so this is chlorination, to kill harmful bacteria. Air, you should know, mostly nitrogen 78%, oxygen 21%, argon 0.9%, a small amount of carbon dioxide 0.03%, and water vapor. Remember, air does not have hydrogen, so we can use it to get nitrogen and oxygen. In order to obtain nitrogen or oxygen from the air, we should do fractional distillation of liquid air. What are the uses of oxygen? Don't say for breathing, and don't say for respiration. Well, we use it for what? We use it in oxygen tents in hospitals, or oxygen cylinders for divers, or in combination with acetylene, it is used to make a flame with very high temperature, and this is used in cutting and welding metals. Pollution, remember, carbon dioxide is a result of complete combustion of fuels that contain carbon, and this causes global warming, causing climate change. Methane is obtained from decomposition of vegetation or from waste gases from digestion in animals, and methane also leads to global warming and climate change. So remember that the gases that cause global warming are carbon dioxide and methane. We also have carbon monoxide from incomplete combustion of fuel, and that's toxic. We have particulates, which means tiny little pieces of solids floating around. This is obtained from incomplete combustion of fuel, and this is damaging to the respiratory system and may cause cancer. Sulfur dioxide is obtained from combustion of fossil fuels because they have some sulfur impurities. Oxides of nitrogen are formed in car engines. Both of these cause acid rain, and you should know that the effects of acid rain is it kills plants and marine. Okay, to reduce the effects of air pollutions, Of course, we need to reduce climate change by planting more trees, a reduction in livestock farming, decreasing use of fossil fuels, increasing use of renewable energy like solar energy and hydroelectric, for example, and use of hydrogen. To reduce acid rain, we should use catalytic converters in the car exhaust, reduce emissions of sulfur dioxide, so we burn fuels that have low sulfur, and flue gas desulfurization. Remember that flue gas desulfurization means removal of sulfur dioxide from the waste gases coming out of chimneys. So sulfur dioxide is an acidic gas. We put on the chimneys, we put calcium oxide, which is basic. This neutralizes the gases that are coming out of chimneys. Ammonia, you should remember that ammonia is used to make fertilizers such as ammonium phosphate fertilizers, and fertilizers are substances added to plants for faster growth and higher yield. You should know that fertilizers should have nitrogen, phosphorus, and potassium, so NPK. If we need another use for ammonia, it is to make nitric acid. And that's the end of this part. So these part 1 and part 2 are the review notes needed for the pre-IG or the core syllabus. And we have part 3, which would involve what is needed for the extended or the supplement syllabus. Thank you for listening.